Come te può capire chi te va bene? Se tu la parla miezza americano, quando si fa l'amore sotto la luna, come te viene in capo di I love you. Fa l'americano.
Alright, here we go. 5.5 graphing linear functions. If you probably noticed there, that's what we're doing in this section. We are noticing we're going to put the fun in functions. Pretty fired up here. Let's get rolling on this. This is the last section of the chapter. Should be a good one here. Let's get rid of this if we can. That's slow. When I think fun, I think of that song right there. Not many songs more fun than that one right there. Alright, so let's take a look at this. This section is actually really the same old stuff we've been doing. We're just going to learn a new notation here. So let's take a look. What we've got here going on is the old way we used to do this. So this is the old way. We've been doing all chapter y equals mx plus b or y equals 2x plus 1, whatever it is right here. This was nice notation. We'd take our tables. When x is 0, what's y? When x is 1, what's y? When x is 2, what's y? Or if y is 11, what's x? So that's how we were doing it. What we're going to do is change up the notation a little bit. So we're still graphing lines, still doing all that. Here's the change. Are you ready for it? We're going to change the y to f of x. Wait for it. Wait for it. Wait for it. It's coming. There it is. Alright. So if we're going to say now that the f of x equals 2x plus 1. So this is now not the old way. This is the new way. So this is the new method. F of x. So I wrote it down here. It reads f of x. That's how you read this thing. This is the f of x. Fantastic. What does that mean? It means f is a function of x. So again, this is the new way. This is the old way. Y equals 2x plus 1. New way. F of x equals 2x plus 1. Old way. New way. Old way. New way. Old way. New way. Old way. New way. Alright, let's just switch to the new way. So why are we doing this? This is going to help us out in applications and fun stuff like that. So if f is a function of x, what we're saying is x is really causing things to happen. So when we look at this, x is what we like to call our independent variable. It's independent of what we were calling y. Y this whole time has been the dependent variable. It's been dependent on x. X causes y to change. So what we're going to do is x is causing it to change. Instead of saying x causes y to change, we're going to say f is a function of x. So as x changes, it changes the f of x. So now I'm changing y to the f of x. I think it's a little slow. Get in there, get in there. There it is. Alright. So it's going to come in there and be our new y. So that's the f of x. So how's this going to look when I go to do it? Should look good. So when I'm saying x is 0, what am I finding? I'm saying, okay, x is 0. So if I put it in my equation, x is 0. So I'm replacing x with, in this case, I want it to be 0. And if you replace x here, you got to replace every single x with 0. Everybody gets replaced. So this x turns into 0. So I'm saying the f of 0 equals what? Let's figure it out. The f of 0 equals, let's simplify this. 2 times 0 is what? 0 plus 1. And then I know what 0 plus 1 is. 0 plus 1 is 1. So I could have done with the old notation when x is 0, y is 1. But now I'm going to say this. The f of 0 equals 1. So we're going to do a lot of notation like this. Fantastic. Can you find the f of 1? Let's do it. How do I find the f of 1? Wherever there's an x, replace it with 1. So that would be 2 times 1 plus 1. And then just simplify it. What is that? 2 times 1 is 2 plus 1. That gives me 3. So the f of 1 is really 3. So this is really 3. Fantastic. Can we find when x is 2? Sure. The notation I'm going to use now is saying, what is the f of 2? So instead of saying when x is 2, what's y? I'm saying, what is the f of 2? We'll plug it in. 2 times 2 plus 1. 2 times 2 plus 1 is 4. Plus that 1 is 5. So I'm really saying the f of 2 equals 5. Fantastic. So we're filling in tables. It's still the same old, same old. We're good to go on that. How about this though? What if it's on the other side of, if it's on this? Now I'm saying the f of x is 11. So remember in my equation I was saying the f of x is 2x plus 1. So now it's in the f of x column. I was saying the f of x is 11. What do I do here? Well, first let's move this guy. I moved that out of the way, so we've got the f of x is 11, so I'm going to replace the f of x. I'm really saying what x generates 11. So it's the same way before I'd say y is 11, what x makes that. So now I'm saying, well, the f of x is 11, so I replaced the f of x, this case, with 11. Now I have to solve this. Let me change colors here to solve this. So hopefully we're good at solving equations. Back from chapter 3 and 4. And let's do it. So I like to draw a little line here and say, okay, 2x plus 1. What am I doing? I want to get x by itself, so I'll subtract 1 from both sides. So that's 10 equals 2x. And then what do I do to get x by itself? I'm going to divide by 2. So really, I'm saying x is 5. So I can fill that in over here. X is 5. But technically speaking, this says the f of 5 is 11. That's what that really means. So we're using this as a kind of a shorthand notation, and it helps out with applications and whatnot. So, what about graphing? Well, it graphs the same way as a line. The only thing, instead of x and y, what does this really become? You guessed it. This really becomes the f of x. So when I graph it, I still think about y equals mx plus b. I just graph it. What is 2x plus 1? Well, it starts at where? It starts at 1. And what's the slope? Up 2 over 1. So y equals 2x plus 1 is the same exact thing as saying the f of x equals 2x plus 1. I'm going to graph them exactly the same. So up 2 over 1, up 2 over 1, down 2, back 1, down 2, back 1. Keep this bad boy going. Boom! There it is. Got a line all the way through it. I'm good to go. Freak out. Got it under control. Let's just try a different function, make sure we're good to go. So these functions can be anything. Let's find these. The f of 3 and the so what's this mean? Instead of the f of x, I'm going to replace every x up here with a 3. So this is really like saying 3 times 3 minus 4. 3 times 3 is what? 9 minus 4. So my f of 3 is just 5. 9 minus 4 is 5. Awesome. Can we put a negative in there? Sure. Wherever there's an x, replace it with the number in here, negative 2 in this case. Minus 4. So I'm looking at negative 6 minus 4. The f of negative 2 equals negative 10. Fantastic. Oh man, I did something weird here. Is that going to mess us up? Let's try it. Whatever is, I'm finding the f of m. So what am I doing? I'm replacing all my x's with whatever's in the parentheses. In this case, it's m. Can I do anything here? 3 times m is just 3m. That is it. The f of m actually equals 3m minus 4. So I just changed the variable. Excellent. Try to trick you up here a little bit. A lot of people plug 20 in for x, but this does not mean plug 20 in for x. This means the function equals 20 at some value of x. So my function up here, this is my function, 3x minus 4 actually equals 20. I got to find the x where that happens. So to do that, what do I got to do? We'll go Christmas colors, red and green. I got to solve for this x. So I'm going to say do the opposite, add 4 to both sides. Looking at 3x equals 24. And how do I get x by itself? I'm going to divide both sides by 3. So really, x equals 8. 8, if I put 8 in here, the f of 8 makes 20. So just be careful. A lot of people just want to automatically put 20 in. It's not right. You got to find the x that makes it true. Excellent. Here's another one of these. You can pause it, try it, make sure you got it down. I'm just going to hammer these answers in real quick, as fast as I possibly can. So make sure you pause it. You're not going to be able to keep up with this pace I'm bringing. Here it comes. This is the f of 5. That means plug 5 in. So we're looking at negative 2 times 5 is negative 10 plus 5 is negative 5. Well, this is saying the f of 8. This is saying the f of negative 2. This is saying what x generates 15. So the f of 8, replace your x with 8. And you're looking at negative 16 plus 5, negative 11. Then on the f of negative 2, I'm saying it's negative 2 times x, which is negative 2. We're looking at 4 plus 5 is 9. And the last one, when does this happen? I'll change color here. When does my function negative 2x plus 5 equal 15? Solve this bad boy for x. I'm looking at subtract 5 from both sides. Negative 2x equals 10. Divide both sides. X equals negative 5. Man, I flew through that. I hammered it. Then graph it. You can use these points to graph it, but I'm just going to graph like line 1, 2, 3, 4, 5. Put a dot. Again, this is negative 2 over 1, so I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Keep it going. Keep it going. Fill it in. Up 2, back 1. Oh my gosh, I went too fast on my line. I hope your line's sharing that.
Excellent. So that's function notation. We got it. The other part is, what if I don't know the function? We can still answer questions just from the graph. Now, we've not been able to graph anything like this. This is a piecewise function that you won't deal with till Algebra 2, but I can still look at it and tell you what's going on. You know, here's my x-axis. Here's my f of x. This is some function, okay? So it's just like, this is saying when x is 4, what is y, essentially? So when x is 4, well, here's 4 right here, what is the y value being produced, or what is the f of 4 at this point? We'll check it out over here. We've got 4 makes 3. So if I was filling in a table, when x is 4, the y value is 3. It's just like filling in a table. Let's try another one. I'm asking when x is 0, or I'm asking what is the y-intercept? When x is 0, what's y? Here it is right here. It's 1. That's the same thing as saying what's the y-intercept? Fantastic. How about when x is negative 1? Change colors here for you. When x is negative 1, I'm right here. What's the y value being produced? It looks like a positive 1. Fantastic. How about when x is 2? No problem, x is 2. What's it making? Boom, the y value is 2. And how about when x is negative 3? Ooh, what is this point called? That is the x-intercept. It's crossing right there. So I may ask you, what's the x-intercept? Well, we know negative 3, the y value there is 0. Same difference. So x-intercept, y-intercept, so they're still in there. So I may ask. All right, so this last one here, the f of x equals negative 3. So really, what is it saying? It's saying, we just did it, plug negative 3 in. No, see the difference here? This is the y value. I'm saying, when does the y value equal negative 3? What x generates a y of negative 3? So it's backwards. Now I'm looking at the y-axis. What makes negative 3? Aha, boom, here it is right here. This makes negative 3. Well, how does that relate up here to the x value? It's negative 4. So it looks like f of negative 4 equals negative 3. So I'm saying this one is when x is negative 4. That's one of the worst looking 4s I've ever made. There it is, negative 4. So this would be my answer. When x is negative 4, that produces that. So that's a little bit different. Be careful, don't get tricked on that one. Why are we doing this? Well, we got applications with this. It helps to put applications in terms of what we're talking about. So let's pretend you got this company that's making money, and it's determined by this function, the P of U. This reads the P of U is 1/4 U squared minus 2U. So what are they making? Well, I got this all about the Benjamins here on a baby. Maybe they're making diapers. Maybe that's why it's a P of U. It smells hilarity. Hilarity. Is that even a word? Hilarious, Mr. Brust. It's hilarious. Where U is the unit sold, P is the profit. That's why it's PU, not because it smells. Read the notation. It reads that what? Profit is a function of what here? It's a function of units sold. And it makes sense. The more I sell, the more Benjamins I have. So profit is a function of units sold. Solds, my grammar's terrible. That is not a word. Solds and hilarity. All right. Find the P of 8. Can we do it? You're like, don't freak out. P of 8 just means whatever is in here, the U, 8, gets replaced up here. So I'm going to say 1/4. Wherever there's a U, replace it with 8. But it was squared. No worries. U squared becomes 8 squared. Minus 2 times 8. So you can do that. If there was 5 U's, replace them all with 8s. Whatever's there, replace them. Let's do order of operations. What do I do first? Exponent. So 8 squared is 64. I'm still multiplying here. It's 1/4 of 64. 2 times 8, 16. 1/4 of 64 is 16. Is this another great example from Mr. Brust? Minus 16. What happens here? If I sell 8 units, how much profit do I make? 8. I make no money. So look, I imagine anything less than that, I'm losing money. So I have to sell at least 8 to make some money. So what does this mean? This means if I sold 8 units, I would profit, let's say, nothing. You would profit $0. Fantastic. You have no money from that. Wow. How about this? What does this mean? I don't know if we're going to solve this one, but can we set up the P of U equals 86,000? What does that mean? Does it mean I sold 86,000 units? No, no, no. I want to know how many units, how many units must I sell to make $86,000. Woo! So this is some great notation to ask some really good questions here. How many uses do I gotta sell to make $86,000? We're not gonna solve that. We could set it up though. All you gotta do is replace the P of U with $86,000, and it equals the function 1/4 U squared minus 2U. We're not gonna talk about that. If you can solve that, I'll give you extra credit. If you can solve that on your own. I don't know about Mr. Kelly or Mr. Sullivan, but that would be incredible. If you can solve that all by yourself, good luck with that. Try the bookwork. Good luck on the mastery check. I hope it goes well.